Columbia, a group working with Toluca, ITESM Toluca, in just west of Mexico City, and a group of you working with students at Wayne State. There will be some control groups, both up in Canada. They will have a team of just Canadian students working together. We will most likely have a team of CATIA students that are just working together, not remote, and that will be a control group. Okay. Course description, extended principles of multidimensional doing engineering applications. Okay, so we're basically kind of going through the syllabus at the moment. These are kind of the major topics that we're going to be talking about: mathematics of curves and surfaces, topology optimization, mathematics of mass properties, the mathematics of FEA and CFD, motion analysis, and visualization and rendering. So you may say, how does the class, how does the lab work together? Well, the class is going to focus primarily on the stuff that doesn't change. Okay, so we're going to talk about the math of engineering, and that will not change over your career. In lab, we will expose you to the actual CAD system, the button clicking and everything else, to do FEA or to do CFD on your CAD system. But more than likely, that's going to change 3 times over the course of your career. I've seen distinctly 3 unique changes in CAD during the time that I have been using it, starting all the way back in '78 when I started on the CAD system. And so back then, there wasn't anything called solid modeling. It was barely a drafting tool. And then it became a surface modeling tool. And then it became a solid modeling tool. And so in your career, you're going to see what we teach in the lab change. But right now, you're going to get the current information, both mathematics as well as kind of the unique thing. What are the tools we're using? Part of you are using, I didn't get this edited. It's supposed to be edited. Part of you are going to be using NX. Part of you are going to be using CATIA. The difference is the Wednesday lab is NX. The Friday lab is CATIA. All of you will be using Altair 10. We'll teach that. All of you will be exposed to ANSYS 13. All of you are going to be using Teamcenter Community and Teamcenter Engineering. They are PLM systems, and we'll kind of teach you about what that is and what it means. All of you will be using Skype. The co-located ones may not, but most of you will be using Skype. You'll be using Google Docs, Google Presentations, Google Spreadsheets, emails, calendars, all of that to kind of keep in collaboration with each other. There's a number of outcomes. I'll let you kind of just read those from the syllabus. We want to get into kind of talking about the project itself. But the outcomes basically focus on the fact that when you leave this class, you should know how to do FEA on a CAD system. Will you be expert at it? No. But you will know the fundamentals of how to set it up, how to use it, how to look at it, and know whether it's a believable result or not. You'll know how to do a very high level of kind of top-down assembly parameterization so that you can basically scale your design up and down very robustly. And this is the outcome that kind of deals with the global collaborative kind of aspects. So you'll experience working across a team, different culture, and different ethnocentrisms. This is the book. Hopefully all of you have it. It is, in my opinion, the best book that's out there for this type of class. I've reviewed dozens of them. We've been using this book for some time. It is costly. If you buy it through the bookstore and you only get new copies, you can go online and occasionally find it as a used book. And a used book is as good as a new book, in my opinion. But it's not a book that I would suggest you sell back. It is a book that has the mathematical foundations of engineering computer graphics. Question?
Are you aware if the international edition is much different than the U.S. edition?
I don't know.
Because I got the international edition and I found it for $25 online.
Okay.
Just
And
if anybody hasn't gotten it.
you may want to come get mine and just flip through
Yeah.
and compare it or something,
And then-
because I don't know whether it's the same or not. Okay, you need to start today reading chapter 19. The chapter 2 is in parentheses, and I would suggest that you kind of speed read chapter 2. Chapter 2 kind of deals with very fundamental, basic stuff, kind of 172 engineering, graphics, simple modeling stuff, okay? So read that as kind of a refresher, remind yourself of what you did in 172. So anytime you see a reading thing kind of in parentheses on the schedule or whatever, that means just kind of blow through it. It's good reading, but it's not the stuff that we're going to be necessarily focused on. The stuff that you will be held for on midterms and tests and things like that are the major readings that we do, which is chapter 19. Okay, you'll see this on the schedule. Don't be confused by it. It just lists the time that all of the other schools are joining in on. And so if I were at Colony, it would be 1 o'clock this morning, 1 o'clock tomorrow morning, I guess. Right? Tomorrow morning is when they would be looking at this course if they were dialed in. And so the reason that we have that box over in the corner is that box hooks to our video bridge here at BYU. Our video bridge allows us to link up to 40 endpoints, cameras. We can link up to 40 different schools into this classroom or into any place that box happens to be pushed to. And so when we bring this into the lab, when we bring it into the classroom and we hook it up, it's so that the other schools can dial in and they can see what's on the screen, and the camera can also be pointed and they can see me lecturing. So they'll see a slightly different kind of view than what you're seeing. But this, don't get confused by it. The CATIA people, you'll notice that you're on Friday, but Saturday very early in the morning is when the NTU students will potentially be linked up with you if they're in class. Now, before I go too far past that, what I should mention is that frequently students will not be attending. The remote students, because of class conflict, because of the time of day, they may be viewing this lecture in asynchronous state. So we're not only filming it and sending it live, but we're capturing it, and we're going to push the lectures up to YouTube. And so you will have reference given to you, YouTube channel, where if you happen to miss class, or you want to go back and review something for midterm or something like that, you'll be able to go up to YouTube, you'll be able to play on a particular lecture and go back to it. Okay. There's a note there about homework and quizzes. I would suggest that you kind of read that. There's also a note in there about a class journal. If you took 172 from me, you got a lecture about doing a class journal. The difference is we're now more adult, we're a little wiser, and this is a recommendation. It is not going to be collected and factored into your grade or anything else. But I would strongly recommend that you keep a journal of your choosing wherein you can track all of the progress and what you've done. That may be a Google Doc that you set up. It may be that you go and buy a journal that's got numbered pages. It may be whatever you kind of do. But I would strongly recommend that you have some place that's a central collection of your notes and activities for this class. Note about teamwork. This is basically where I wanted to get to. There's a breakdown of kind of the points. I think on your syllabus, this says 160. That's a typo. It should say 140. So if you want to correct that. So there's points for homework, there's points for individual labs. The labs are things that happen on Wednesdays and Fridays. The group project, which we'll talk about in just a minute, is worth a full load of points. Midterm, 150. The final presentation, which is on your group project, is another 140 points. The final exam, 150 points. That should add up to 300. So here are all the labs. You'll notice the first lab is team building exercise. The second lab deals with team center engineering, which we'll explain what that is. The one after that is kind of a team building exercise. We go directly into a top-down assembly skeleton lecture. The reason for that is we want you to model your car in such a way that at the end of the semester, if you want this car to be 3 feet long, a meter long, you can change a few parameters and everything will automatically scale and update. It is a technique that if you learn and learn well, when you go to industry, you'll immediately find that you are put on the most challenging modeling activities and projects, because this is where they get high reuse of CAD data. The old way of bottom-up modeling is very outdated and it's cumbersome and hard to reuse. But a top-down skeletal approach is one that will put you in the driver's seat. Anyway, the list kind of goes on there, all the different projects. This is basically the collection of very expensive RC race cars that we have. This one, I think, if you buy it from one of the hobby shops, you'd pay about $250 to $300. You got it for half that, roughly. But the intent is that we're going to reuse these over and over and over again. So those are all the different models that are out there.